In this video, we will overview different simulation clocks available in the Cameo Systems Modular Enterprise Edition using Simulation Toolkit. The first clock will be a built-in clock, which is almost like PC clock. The second one will be internal simulation clock, where the time is propagated not based on the continuous flow, but based on the time events and duration constraints in the model. And the last one, which allows you to use full control of the time, it will be model-based clock where the time is propagated custom by increasing a custom property which is used to represent the time. So the first one, what we have here is in the activity diagram, we have workflow. We created some algorithm here, for example, for testing. And we have swim lanes, so we have parts of our system performing this test. And here we have the flow, but we don't know, is it correct? So we can execute and try to understand, is this logic correct? So we run it, run with context. We can also, switch on the timeline chart with activities, so we would see what is performed by whom and how long it takes. And then when we execute it, like run here, we see the flow started, we see the duration of each task, and we see a flow finished. But the problem is here that even we get the result of the execution, but the problem here is that the duration is based on the animation speed. If you will slow down, duration will be slower. Let's do this again. So let's longer, duration will be longer. Let's run again. And they can even slow down more. You see that now it takes 1 second. Default unit in this, I can show the clock. Default unit in this type of built-in clock is millisecond, and it is used as the default one when you execute your behavioral diagrams. The reason for it is that it gives you ability to validate the logic. So you can see that actually flow goes in the right way, the right elements were used, and for example, that all inputs are available for this to start execution and then finish, when finished, go here. So we can check that, but it doesn't give us duration analysis precision. So what we could do here to improve. So first of all, we would need to say how long it takes to execute each task, because otherwise no information about that, right? So to do this, we are using duration constraints. Here we see under the common toolbar duration constraints, I can apply and say, for example, 15, and then even I can use unit. I could use here variable, but then I could not use units. Let's say this one I will skip, or I could say this one takes 0 seconds, because this was actually doing all the job. So this one was just like double checking that, and then let's say 2 seconds. Let's say this one will take 15 seconds. This one will take again 2 seconds, and this one will take 12 milliseconds, and this one will take 30 seconds, and this one again maybe like 30 seconds, or maybe 2 minutes. Okay, could be even longer, let's say. Now, if I will run like this, like just executing this diagram, let's say with context, if I want to see, who is performing not only the activity, and then turn it on, the activity representation, the timeline, run this one. So now you see it takes the time. It takes the time based on those duration constraints. Still, the unit is millisecond. It takes the time. It tries to be as fast as real time, right? So let's say I'm increasing this animation speed to 100%. Still, this takes time. And you see that the actual value depends on the speed how the animation was performing this task. So it's 15,600 milliseconds. And this was zero, right? Because it was zero, right? And then it switched to this one. It's almost 2 seconds, but it's a little bit more. This one is a little more. And if I will increase animation speed, decrease animation speed, so this becomes even less accurate, right? And so this is one problem. Another problem that those long events, like 30 seconds, now I need to wait, right? So for this long event, and what if I want different unit, right? So now let's see what other type of clocks we can use to improve this duration analysis. Let's see here, for example, 30 seconds, but this now we will need to wait 2 minutes. So this is not suitable for us. It could be 2 hours or 2 days, and we will need to wait that, right? So let's stop this. Here, what we can do, even with the built-in clock in simulation config diagram, you can create simulation config, set your execution target as the test context here, as that main block which you execute, go to the specification, and here in time properties, you could specify ratio, clock ratio. So this property works with the built-in clock, and here you can say the speed of the clock compared to simulation clock. So for example, if your simulation takes 1 millisecond and you say here 1,000, this will execute as 1 second. So it will be executing slower by 1 second. Now, if I will say 0, if my simulation takes 2 minutes and I want that it would execute, 10 times slower, I would say 0, 1, right? It will be executed 10 times faster, 10 times faster, right? So that clock ratio works with the built-in clock. So let's try now to run this built-in clock. Let's go here, let's run it. Oh, I'm sorry, I'm running different one. Let's switch to built-in clock and run it. Here you go. So you see that it executes faster, right? So it's jumped here and now jumped here. And let's continue. Yeah, let's continue that it would finish. And let's stop at the end. Yeah, let's stop it. So this did the job, it produced the results. It produced them 10 times faster than previously, not real time, but still the delay is based on the animation speed and then delays between the tasks because the animation takes time to switch from one to another. So how we can improve? So that's for that reason we actually implemented model internal simulation clock. This internal simulation clock producing time events. We can go to documentation. Here we see built-in clock and then internal simulation clock. It's producing time events based on the duration constraints and based on the time events in the model. Now let's go here. Let's see in the simulation and terminal simulation clock. Again, I created simulation config. If we go to the specification time properties, here we can use those properties. Those are the start time. So it's once you specify start time, immediately the internal simulation clocks is used. Then end time, you can specify when to finish simulation. Step delay, and this step delay, and here you can read about it. It gives the delay on every step execution that you could monitor the results in the model. So for example, if your step size is 1 second and your step delay is 1, then every second will look like as it is second in the simulations. If your step delay is 0.5, it will execute it twice faster. But still in the results, it will be same second. So here, for example, we have time unit second, step delay step size 0, 2, and no step delay. So no step delay, it will be as fast as it can. And 0, 2 is the step unit, how the time will be increased. So one thing that we will get is that time is second, in units is seconds. The good practice is to specify the unit as the smallest step you need. You have those events in the model, and then you don't need smaller steps if there is no smaller events. And then step size based on that, again, like 200 milliseconds. I wanted to see it in seconds, so I can specify like that. And then one more thing is the time variable name. It produces the time clock value at any moment, so you can track that, read from this, not write to this, but read from this. Okay, so now let's see and how that works. So I will run the same activity diagram, but now with internal simulation clock. Execute it. It ran through, and you see here, those are results. The results are precise. You see, like 15, then 0, then again 15, then this one was 15, right? This one was 2 seconds. Here was 2 seconds, so this 15. This one is 0. This is 2 seconds. This is 15 seconds, right? And then 0, 2. Like, which one is 0, 2? Like, again, this guy 2 seconds, and this one 0, 2. Right? It should be less, right? So we can increase, but this could be the problem of the unit, right? Depends on the unit which you select. We selected, right? If we selected that unit is 0, 2 seconds, right? So that's the granularity of the step. Even we have here 20 milliseconds, the step size was not granular enough to detect that. So that's why we got this jump in time, which noted that happens, right? But it didn't note that when it started, when it ended precisely, right? So C02 based on that, and then rest of that is rest of that is based on those timings correctly, right? One more thing, what we see here is that the only thing what propagates the time is those duration constraints, so nothing else. So this clock is very convenient. This clock is the one which is used 90% of the time when you do any duration analysis, because you just get the duration of the steps based on the duration constraints. And if the duration constraint is not assigned, so then the time is 0 of that event. It pretty much don't propagate the time. So here we see, and we can track, small and short and long events. It doesn't really, simulation speed depends on that. Now I will try to fix that problem with 0, 2. I will go to my I can leave that here. I will go to my simulation configuration, terminal speed, go to time properties, and say 0, 0, 0, 0, 1. So that's 10 milliseconds now, the step size, right? And let's run again the same model. Okay, so here we see that it looks like 0, but if you will increase this, here we see the value. And the value is actually 20 milliseconds. Here we have that captured, 20 milliseconds. So that's how we get the precision in the duration. And you can have very complicated logic in your model, and through different behaviors. And when you run it, it's very precisely tracking it, because the only thing what it notes as a time consumption is those duration constraints and some other time events, like on state machine transitions as time events and so on. So this clock again is using those properties. If you go to simulation specification time properties, if you want to switch to that clock, just specify start time, and that's it. It's immediately will start using this clock, and then you need to choose like time unit because maybe you don't want milliseconds or seconds or something else like nanoseconds or so, and then step size, and then step delay if you want to delay visual results generation. But if you will use this time without the duration constraints, this clock without duration constraints, which is at the beginning is the case, you might not have duration constraints. So all the tasks will show that they were performed in 0 time. So that's why this clock is not a default one, because at the most cases in the beginning, you have no duration constraints, which are required for that precision of the duration analysis. So this is the built-in, this is internal simulation clock. So it propagates time automatically, and it's kind of precise. Now you might want to ask, why we would need this model-based clock. This model-based clock is actually the one which is partially covered with this internal simulation clock. The model-based clock, what it does, it actually allows you to specify which property in the model represents the time. And then you need to increase the time by yourself. So for example, here in this model, we for that, and why you would need to do this, it's pretty much to have full control of the time. For example, let's say that here in this simulation, we have some events which are very long, let's say like 2 minutes or maybe years, and some events which are very short, like 20 milliseconds or maybe microseconds, right? So those short events, you want that clock would tick very granular way, right? And for the long ones, you don't want that granularity, that clock would tick the granular way, because you know that nothing will happen. So you can control that. You can actually increase and decrease the step size because you are controlling the time property, right? So for that model-based clock, what we created here, we created model-based clock. Here we created a state machine. So it has fast and slow clock increase loops. So here in the fast one, we increase time by adding 1 second every iteration, right? Time, add 1 second, and if it goes as fast as it can, we really don't care, because we just want final result. Now here in that slow, we have time increased by 10 milliseconds, right? And then we switch between fast and slow based on the property value. If it is slow true, then we switch to slow clock. If it is fast, then we switch to fast clock. And at the same time, we run this same activity. Yeah, here I will change it to 2 minutes. Right? We run the same activity, and what we get here, just in two places, we switch the clock to slow true and slow false, in order to have more granular calculation of the time increase of the time unit, in order to get this event noticed correctly. So compared to the built to the internal simulation clock, this model-based clock will give us ability to have less steps, so it will be faster at the end of the calculation. But in most cases, you don't need that precision. With internal simulation clock, you can achieve that result. So just model-based clock was the reason why we created internal simulation clock, where the time unit is when the time is increased automatically instead manually increasing it through the model. But again, in the model-based clock, you have this with more precision. So I will run this model-based clock again. Not again, but first time. And you see that now it executes. It's in the fast mode. At some moment, it will switch to the slow mode. You see slow mode. And this event happened, right? And then switch back to the fast mode. And you got results, right? So now Now I will stop it here. Will increase this one, and you see that it's actually captured that. It captured those 20 milliseconds here. If it would be still, 1 second as an interval, if it always would be fast, this would not be captured. It would be captured just as 0 or as a 1 second, because it would jump through this. So in this video, we did overview of the different simulation clocks. Let us know if you want to receive the sample project, and more about those clocks you can find in the documentation of the Magic Model Analyzer Cameo Simulation Toolkit, and different names, but same tool. And here we see those documentation describes different clocks: built-in clock, internal simulation clock, and model-based clock. Thank you for watching.